Hey everyone, welcome back to BIOSKUL. This is Dr. Gayatri. Today I am with a very important topic from ecology, that is theory of island biogeography. So guys, please watch the video and get a clear concept about island biogeography, and at the end we are going to solve some previous year CSR net question related to this topic. So please watch the video till the end. Thank you. So let's get started. Theory of island biogeography. Robert MacArthur and Wilson in the year 1963, they developed a model to explain the process of succession on a newly formed island, and their idea are termed as theory of island biogeography. It is also known as equilibrium theory. So before going to know about the theory of island biogeography, let's know what is island and what is biogeography. An island, it is a piece of ground which is surrounded by the water. And what is biogeography? Biogeography, it is the study of distribution of plants and animals in a geological space and through geological time. That is known as the biogeography. So, island biogeography, it is a field within the biogeography, and it attempts to establish and explain the factor that affects the species richness. Okay, so what is the species richness? So the species richness is the number of species present. Okay, so MacArthur and Wilson, they focus that the two factors that affect the biodiversity. So what are those two factors? One is the distance between the island and the mainland, and the second one is the island size. This is very important. So what are the factors that affect the species richness? One is the distance between the island and the mainland, and the second one is the size of island. So the island biogeography theory, or the theory of island biogeography, it explains how the distance and area, they combine to regulate the balance between immigration and extinction in an island population. The MacArthur and Wilson's theory of island biogeography suggests that the species are rapidly arrived on an island that either may thrive or sustain, or they may become extinct. First, the species which are arrive on the island at different rates. Okay, the species which are arrive on island are known as the immigration, and the immigration of species, of the new species, they are at different rates. Like some animals which are the winged animals, or the seed dispersal mechanism of plants, and the plants with the seed dispersal mechanism, they arrive the island more quickly, and other species, they may arrive an island at later stage. That's why the immigration rate in graphically represented by a curve. Okay, so on the other hand, extinction also, it starts very slowly. Okay, very slowly, and suddenly it rises. As you see here, it suddenly rises. Why? Because the species which are the later arrive in an island, the competition, it become increases, and the more species, they are likely to go extinction. Okay, so the species which are earlier arrive, that species are known as the R selected species, and the R selected species are the better dispersal. Okay, and the species which are later arrive in an island, those species are known as the K selected species, and the K selected species are the better competitors. I have a video on R selected and K selected species. If you want to know in details about the R selected species and K selected species and their difference, then please do watch the video. Okay, this is a very important point. Okay, the MacArthur and Wilson theory of island biogeography, they propose that the species richness, it depends on the two factors. What are those factors? One is known as the size of the island, and another one is the distance of island from the mainland. Okay, so based on that, there are two hypotheses are there. The first hypothesis, it is the species area hypothesis. The species area hypothesis, it is that if the size or area of island, it is increasing, then the number of species also increases. Okay, Okay, if there are the more space, then the number of species will be more. Okay, similarly the extinction rate will be less on larger island. Why? Because the population size is greater and they are less susceptible to extinction. So what is the species area hypothesis? It suggests that if the size or the area of island is increasing, then the number of species is also, if area is increasing, if area of island increasing, then number of species is also increasing and the extinction rate it decreases. Okay. And the second hypothesis is known as the species distance hypothesis. Okay, first one is the area hypothesis, then second is the distance. Okay, if you consider that the distance of the island from the mainland is far, then what will happen? Then the number of the species will be decreases. If the distance is far, then why should the species will travel a long distance? Never. Okay, if the distance between the mainland and island is far, then the number of species decreases. On the other hand, if the distance from the island and mainland it is nearer, okay, if the distance is nearer, then what will happen? Then the number of the species in that island it will increases. Okay. So let's see here in the graph. In the graph, as you can see, this curve it represents the immigration rate, and this one it represents the extinction rate, and this point it is the equilibrium state, and here this P it represents the species pool. Okay, that is the total number of species present for the colonization. Okay, so first in the species area hypothesis. Species area hypothesis, like if the area is small, okay, if the island area is small, then the number of the species will be less. If the island is the larger island, then the number of species that present will be more. Similarly, if the island it is near to the mainland, then number of species will be more. If the island that is far away from the mainland, then their number of species will be less. So we can say that large island and the island which is close to the mainland or that is near to the mainland have most species, and the island which is the small island and far from the mainland have the fewest species. So here you have to memorize one thing, that the island which is near to the mainland and the island which is larger have more number of species, whereas the island which is far away from the mainland and the island is smaller, that have the few species are present. Okay, this is the all about theory of island biogeography. It is very simple. The theory of island biogeography, it depends on the two factors. One is the size of island and another one is the distance of island from the mainland. Okay. So now we'll see the previous year CSIR UGC NET questions. According to MacArthur and Wilson's equilibrium theory, which one of the following is true? Larger island and island closer to the continent are expected to have more species than smaller and isolated island. Yes, it is true, as I told you before. The island which is near to the mainland, if it is near to the mainland, then more species will be immigrated and the number of species will be more. If the size of the island is large, then or the larger island, then also it will have more number of the species. It also makes the sense, right? If that island is the smaller, if the space is smaller, then there obviously there will be a fewer number of the species. And if the island is far away from the mainland, then also the less number of species will travel to that island. Okay, so the correct option is option A. Okay, now comes to this one. Forest fragments. Okay, forest fragments in an agricultural landscape can be viewed as island of habitat in an ocean of non-habitat. MacArthur and Wilson's island biogeography model can be used to predict pattern of species richness in these forest fragments, which are represented in graphs below. Okay, so the MacArthur and Wilson's biogeography, it depends on the two factors. One is known as the area or the size of the island, and second one is the distance of the island from the mainland. Okay, so here in graph you can see the graph P and Q that represent the area, and graph R and S that represent the distance. So the correct answer will be one from the P and Q, and another one will be from the R and S. So let's see the graph. Fragment area, it is the part of the main area. Okay, and the y-axis, it represents the species richness, that is the number of species present in that fragment. Okay, so if the area size it increases, then or the size of the fragment area is increases, then what will happen? The species richness, it will also increases. Here you see, here the area is smaller and the species richness is smaller. As the area it is increases, then the species richness is also increases. Okay, so this one is the correct. Let's see in the Q. Here you can see that as the area increases, the species richness is gradually decreases. So this one is wrong. Okay, let's see the R. Distance to nearest fragment. Okay, if the distance is increases, then what will happen? The species richness, it will decreases. But here you can see, as the distance increases, the species richness is also increases. Which one? That is wrong. Distance to nearest fragment. Okay, as the distance increases, then also here the species richness is decreases, and in nearer there are the more species are present. So this one is correct answer. So which one of the following combination of the graph correctly represent the prediction from the model, that is P and S? That is option B is the correct answer. Okay, then the next question. Following figures show the MacArthur and Wilson's equilibrium model of biota on a single island. In this figure, terms A, B, C, D in order are, the A, it represents the immigration, and B, it represents the extinction, C, it represents the equilibrium, and D, it represents the species pool. Okay, I have explained you in my previous slide. I have explained you in the slides. So the correct answer is option B. Okay. Then the equilibrium model of island biogeography proposed by the MacArthur and Wilson assumed that number of species on an island represent a balance between resource consumption rate and predation rate. No. Birth rate and growth rate. No. It represents the colonization rate and the extinction rate. So option C is correct answer. And option D, it is the speciation rate and habitation rate. This is also wrong. So the correct answer for this question is option C. Thank you so much for watching this video. If you find this video very helpful, then please don't forget to like, share and subscribe. Bye bye. See you in my next video.